Rightio, part 4, here we come. Let's see what we're doing now. Simplify. Your answer should only contain positive exponents. Well, this isn't too bad, is it? Number by number, 2 3s are 6. First index law, x squared times x cubed. Add the indices. 2 plus 3 is 5. 6x to the power of 5. This one here, when you've got power, when you've got an expression, a product being raised to a power, each one gets raised to the power 2 cubed by p cubed, which is, of course, 8p cubed. Nice and easy. We can race through these ones, can't we? Over here, oh look, 3b divided by 3b. Well, 3b goes into that once and into that once. Something divided by itself is 1, almost always. Not so sure about 0 divided by 0. You want to check out Mathologer? He does a great explanation of expressions like that. Really good YouTube channel if you're interested. This one here, I'm looking for something to cancel. The 3 can't cancel with any other number. This is a y cubed, this is an x cubed. There's nothing I can do. Everything's expressed with a positive index. That one just gets left alone. How nice was that? Rightio. Next one here, we can cancel common factors. These are all factors being multiplied together. These are factors on the top. So let's go to it. 3 and 3. They go into each other once. There's an n on the top. Can cancel with one of these n's on the bottom. I'll make that a squared. Here I've got m squared. M squared is a term on the bottom. They can cancel. So now my numerator is 1. On the bottom I have 1 times n squared. Now we need to expand this as well. 2 cubed and m squared. When I cube that, we multiply the exponents. 2 by 3 is 6, so let's just make that look a little bit nicer. We're going to put that coefficient in the front. 2 cubed is 8, and let's go alphabetical. M to the power of 6, n to the power of 2. And we're done. 42. Here we've got lots we can start simplifying inside the bracket, but what I note is this entire bracket is to the power of 0. What do I get when I have an expression to the power of 0? 1, so long as that term, of course, doesn't equal 0. Again, check out Mathologer. Very clever guy from down in Victoria. Anyway, there you go. That whole bracket to the power of 0, that's nice and easy for us to simplify. That equals 1. A few inequalities. Most of us were pretty good on these, but yeah, we don't see them all that often, so let's just make sure. X is less than 4. So obviously we're going to have something to do with 4. Well, this is the only one with 4 actually circled, so it made it pretty easy. Just a reminder, the open circle versus the closed circle. A closed circle is for less than or equal to or greater than or equal to. Open circles are for the strictly less than or strictly greater than. This one's pretty easy though, isn't it? That's the one which shows x being less than 4. Over here we have r is greater than or equal to negative 6. Just as a little point, each of these where they've got x and r there, if you were doing these in the exam, I'd really like you to be labeling that axis so it's clear what you're doing. This is the r axis this time because they're telling us it's r. Whereas r greater than or equal to negative 6, well, there's a negative 6 one. Greater than means to the right of, and equal to as well, it's shaded in. That's the one we're after. Let's keep going. Sketch the graph of each linear inequality. So to sketch the graph, well, these aren't in the y equals mx plus c form, so let's just find a couple of points. So what we do with these, let's pretend it was x plus y equals negative 2. And then we just find the intercept. So when it's set up with the x and y term on the same side and the number on the other side, intercepts are the easiest to go with. If x equals 0, the y-intercept is negative 2. And if I let y equal 0, so let's just say that if I let x equal 0, so you can do all this in your head. What does that give me? It gives me y equals negative 2. That's my y-intercept. And to find an x-intercept, you let y equal 0. And in this case, that would be x plus 0 equals negative 2. So x is going to equal negative 2. So I should have negative 2 as my intercepts. There they are. X plus y is greater than or equal to negative 2. What do? We have to test a point, don't we? Let's test the origin. So long as it's not on the line, that's the easiest point to test. So if I substitute in 0 and 0, I get 0 plus 0 is greater than or equal to negative 2. Remember, that's the one we're looking for there, isn't it? Is 0 greater than negative 2? It is. So I want the side shaded to include that test point. So even though I had 2 to choose from here with negative 2 and negative 2, the one I'm after is C. That's where x plus y gives a total greater than -2. This one here is not so bad. It's in y equals mx plus c form, except of course it's an inequality, but the y-intercept we can see should be -1. So straight away we can rule out, well, that's one we can keep. Well, there's only one we can look at there, isn't it? Let's just check, is the gradient -1/4? If I go down 1 and across 1, 2, 3, 4, definitely the one I'm after. Check the greater than or equal to as well. If I test 0, 0, is 0 greater than 0 minus 1? Yes, it is. So the side with the origin should have been shaded as it was. So we know we got the right one. Rightio, solve each system by graphing. Well, this is going to be a little bit messy. You could use your graphics calculators for this if you've got one. But we'll use a little combination of Desmos and our own brains here to sort these out. So with the first equation here, x plus y equals -1. Well, again, we've already seen this, haven't we? If I let x equal 0, y is going to be -1. And if I let y equal 0, x is going to be -1. So the x-intercept and the y-intercept are both equal to -1. That's enough information to draw a line. 2 points is all you need, remember that. Here I've got x minus 2y equals 8. So for the second equation, first of all, if I let y equal 0, I'm going to have x equals 8. So the x-intercept equals 8. And if I have x equaling 0, I've got -2y equals 8, or y, the y-intercept is 8 divided by -2, -4. So a very quick sketch. You would, of course, need graph paper or something to do this on so that you could do it accurately. But just a quick idea of what it's going to look like. There's -1, -1, and we can have a line going through those. That's my first equation. My second equation, the x-intercept was 8. Well, using that sort of scale, I've probably gone a bit far, over there somewhere. Y-intercept -4. So we should be crossing over somewhere in this quadrant, this fourth quadrant. Let's not get too excited about it. Let's go to Desmos and see what Desmos tells us. That's probably what we're after, isn't it? If you had graph paper, it'd be pretty easy. X plus y equals -1. X minus 2y equals 8. And, as expected, crossing over in the fourth quadrant there, somewhere around, and in actual fact, right at the point, to -3. So that's the point we're after. Of course, it's a bit hard to tell from my little chicken scratching estimate there, rough drawing. Make sure you always label your axes and the origin when you're sketching these lines. But that's the way you do it. The other one over here, I won't try and do the chicken scratching again. You'll see the idea. X plus 3y equals 3. And 4x plus 3y equals -6. And then you find where they cross over, -3, 2. Now, I'm going to assume you're okay with those. If you want to ask more about those, you can get your teacher to have a look at those. Same procedure every time. When they're set up with x plus y or x plus y, those ones you want to sketch by finding the two intercepts, drawing the line through those two intercepts. If you've got a y equals mx plus c, that one there I'd just rearrange it a little bit first, wouldn't I? If I'm just looking at 50, y equals 2x minus 3, just multiplying through by -1. So I've got my y-intercept at -3, and I need to find another point, and I've got my gradient equals 2. So I can just go up 2 and across 1, find another point, join them up, and then you see where they cross over. Hopefully you've had some luck with that. If you need some help on your calculator, you can look up YouTube. I don't have the emulator on this computer at the moment, so I can't show you with that. But otherwise, you can just come and ask me, or your teacher, and I'm sure they'll be happy to help. Alright, how long has this video been going? Do you think we need to cut it short? 10 minutes? That'll do. Let's get on to the next one. Have fun.